In this video, we'll discuss a PV diagram. So let's say this is PV diagram. So far we have discussed PT diagram and TV diagram. So now we are going to discuss PV diagram. So here you can see actually the figure, the left hand side. This is actually the PV diagram for pure substance, and this is actually the figure. A piston-like cylinder, a piston cylinder device. We discussed in our last video. So this is the same thing. In this case, consider we have this piston cylinder device, and the pressure is here 1 MPa, temperature is 150. We have some energy, we are providing some energy from the bottom of this cylinder. And if you can remember, when we discussed other problem for this similar device, so we had 1 atmosphere pressure, and initially it was 20 degrees centigrade temperature. Here we have, look, it is 150 degrees centigrade temperature and 1 MPa the pressure. So this PV diagram is more or less same like the temperature and the volume diagram, but when it is temperature volume diagram, you can see we observed the curves like this. It is somehow initially temperature was like this, then it was the constant phase and the temperature increase or something like that. You see, it is the curve was something upward directions. But here what we observed, you see, we will see when it is a PV diagram, it will be kind of the downward directions. The curves, it will be downward directions. That's it. That's the only difference. So let's discuss quickly to get some exact understanding, some precise understanding. What we will do in this case, it is the temperature is constant. Look, the temperature is constant here. So we will only vary the pressure, and we'll check the pressure and the volume with constant temperature line. So what will happen, initially we have the 1 MPa and 150 degrees centigrade temperature. Now what we will do, we will remove some weight from here. You can see this arrow, so we will remove a little, let's say some weight gradually, and that means if we remove some weight from here, the pressure will decrease here, isn't it? It is 1 MPa, so if we remove this, pressure will decrease little bit, and that will help this compressed liquid to expand its specific volume, because when you are reducing this pressure, the specific volume of this compressed liquid will increase slightly. And what will happen as the pressure reaches, suppose when you are removing this weight, so when the pressure reaches the saturation pressure value, which is actually for this case it is 0.4762 MPa. So initially it is 1 MPa. So when it will reach this pressure, okay, the water start boiling. So that means vaporization process will start and phase change process will start. And at this stage, when the vaporization will start at this pressure, the temperature and pressure will remain constant at this phase. This is actually this phase where the temperature and temperature is constant. So pressure is also constant at this phase. When every single drop of the liquid will transform to the vapor, then we will experience again the pressure drop here. So this y-axis is actually the pressure. So initially we had the pressure, high pressure, we were removing the pressure, that means you see the pressure decreasing. So when the pressure reaches this saturation pressure, then it will be constant, the temperature and pressure. It will be constant, no change, no phase. When this phase change process completed, that means every single drop of liquid transformed to vapor, then we will see the pressure drop again. So that will happen, and you see for different temperature, you can see two different lines here. So if we repeatedly follow this process, then we'll get similar paths like this persistence processes. And from here actually we discussed, so this line, we say this is actually the saturated liquid line, this is the saturated vapor line, where they are intersecting. We say this is the critical point, and this section, it is the compressed liquid region, this is the superheated vapor region, and this is actually the liquid plus vapor region just under this dome like shape. So that's you already know. Now what I want to discuss here, how the specific volume is changing. So if we already know, guys, this is actually the pressure, this is the high pressure, and now pressure is decreasing this way. If we draw a line like this, let's say if we take a point here and another point here, so let's say this point is P1, this point is P2. Okay, so this point is P2. Now what will be the change of the specific volume? So let's see, if we draw a line like this, and it is it's almost same, it's not that much change. So this is actually the delta B, or the rate of this change. You can see this is very negligible change of the specific volume for this saturated liquid region. But if we take a similar pressure drop here, let's say this is another point for this superheated vapor region. If we take another point, this is P3 here, and it's distance, so we will take a similar distance, so let's say here. So we can say, okay, this is actually P3 and this is actually P4. So look, we took this similar pressure, we tell this is delta P, this is delta P. So for the same pressure drop, we will experience here high delta V. That means the higher change of a specific volume. So what we found here, guys, with the same at constant, definitely it is at constant temperature. So at constant temperature, if you decrease the pressure delta P, then at the liquid region and a equal amount of pressure at the superheated vapor region, what we will found that the specific volume will decrease here, but the specific volume increase here, and this increase, it will be significantly higher than the liquid region. I'm telling again, the specific volume change will be significantly higher in the vapor region than the liquid region, especially for the PV diagram. So that's actually the observations from this PV diagram. So later on we will discuss the critical point, the triple line and the triple point. So that's also important. So we'll discuss the triple line and triple point in another video. So if you have any confusions, maybe we can discuss it during the lecture. So that's it.